Hello and welcome to Saturn Stratified Junction tutorial. In this video, you will learn how to set a 3D stratified water flow computation case, including a hot and a cold inlets. This unsteady computation will be post-processed and I will show some interesting and relevant data. Do not hesitate to open related PDF file where you will find further details. As usual, I highly recommend to verify if you have data package of this computation case. If not, please visit our website and download it. Regarding the case, and as you can see on the screen, there is a curved pipe including 2 inlets and 1 outlet. Inlet number 6 corresponds to hot inlet in which water flows at 4 liters per second with a temperature of 38.5 degrees Celsius. Inlet number 2 corresponds to cold inlet in which water flows at 4 liters per second at the temperature of 18.6 degrees Celsius. Outlet number 7 corresponds to the outlet in which water exits. In addition, the pipe diameter is 0.4 meter. Regarding mesh characteristic, we use an unstructured mesh type with a total of 16,320 elements to perform a quick computation. Let's now set up the case with Saturn graphic user interface. So, like in the previous tutorials, I created in the CFD directory a folder called Stratified Junction, in which I also created the case where all main folders are located. Before moving forward, make sure the mesh file is already in the mesh folder. So to do it, you must copy paste the file in the mesh folder. Same thing for the source file here. So we're going now to open Saturn graphic user interface by typing the following command. And here we are. Graphic user interface is well opened. I will now present you all main settings for this case. So the procedure is always the same. We will move tab by tab, starting from the calculation environment down to post-processing or performance settings before clicking on Run Computation. So let's start with Mesh tab. Make sure the mesh is well imported, so normally the local mesh directory is well set and you will just need to click on here and to add the previous mesh file. So here we are. Regarding preprocessing, nothing to add in volume zones. Make sure the 4 boundary zones are well created with the selection criteria settings. So I mentioned all the selection criteria earlier in this video. Make sure you follow the same parameters and you will be all done with the mesh tab. So let's now move to the calculation feature. Regarding flow models, we will use standard Eulerian single phase, no additional features. Regarding turbulence models, a K epsilon linear production is selected and we will add 0.03182 meters per second as reference values for the velocity scale. So you're done with the turbulence models. Regarding thermal model, you can activate the energy equation by selecting temperature Celsius here. So you will be done with thermal model. Regarding body forces, make sure you add minus 9.81 meter per second squared in the gravity field in the g-axis, and you will be all done for body forces. No need to add further or additional species transport, and your calculation features tab will be all set. let's move to volume conditions. Make sure initialization and physical properties are both ticked, and you can click on all underscore cells to set fluid properties and initiate values. So let's start with initialization. Velocity, nothing to add, you can leave all defaults. Values, you can now initiate the temperature values by typing 38.5 degrees, which corresponds to the hot inlet temperature. Regarding physical properties, make sure you have well filled all the fields here. You will find all the values you need to set in the PDF folder. So I will just show you here how to create a user law. So you must select user law here, click on this green button here, and you can type the formula here. Make sure the reference value is well filled too. Regarding viscosity, same thing, you need to create a user law, clicking on the red button here and typing the formula you will find in the PDF tutorial. So once all of this is done, you have well filled the volume conditions tab. Make sure to regularly save your XML document by clicking on the save button here. And we can now move to boundary conditions. Make sure all nature are well defined. Nothing to add in the wall tab. You can now move to cold inlet and define the velocity values as follows. Regarding hydraulic diameter, it's 0.4 meter, and the thermal value here should be 18.66 18.6 degrees Celsius. You can save. Regarding the hot inlet, same values for velocity and the turbulence field for the hydraulic diameter, but you need to increase thermal values up to 38.5 degrees Celsius. Nothing to add for the outlet tab, and you will be all done for the boundary conditions. Make sure to save here. Regarding coupling parameters, nothing to add here or to change. You can now select time settings and make sure all the values here are well defined on your side. So we want to create an unsteady computation, so you need to select time varying adaptive option, the simplex option for the velocity pressure algorithm. You can increase the CFL number up to 20. Then you can also make sure the maximum Fourier number is 60, and the stopping criterion here, number of time steps, should be 100. So you will be all done with the time settings here. Now you can select numerical parameters. Make sure green goes with iterative handling of non-orthogonalities is selected. Handling of transport 2, improved pressure interpolation 2. Regarding equation parameters tab, you can go to the clipping tab and make sure the minimal value of temperature is 18.6 and the maximal value is 38.5 degrees Celsius. So now let's move to the post-processing tab. The output control can be left by default. Here, rewrite a tab, results, and make sure the output error and time step value is 10. Regarding mesh, nothing to add, and regarding the monitoring points, you can add 4 probe for monitoring points, coordinates, just like here. All the values are also available in the PDF tutorial. So once this is done, you can also add two profiles here by clicking on add, and you can add temperature as variables and define the expression. So the expression is also available in the PDF file. Here you can type z equals minus 0.2 plus s times 0.4. That means you can have a range, because s is a parameter that is always between 0 and 1. So that defines the profile 16. Same thing for profile 32, except that the x coordinates is different. So now you are all done, and you can proceed to the calculation. By clicking here, you can set a number of processes down to 1 or up to 4 depending on your architecture. And now I will run the computation. We are now done with the computation process. We'll now move to the post-processing step, where I can show you some relevant results. So before showing you the results, let me remind you the aim of this tutorial. The goal of this tutorial is to simulate a stratified flow. Remember, we have two inlets, so a hot one located on the right here, and a cold one located in the middle, and an outlet on the left. So let's track temperature evolution by clicking on the play button just right here. And as you can see, the results are pretty remarkable, because we can notice that the cold flow influenced the main hot flow on the right and on the left of the junction. Another thing interesting, if you want to have only the blue cells colored, is to create a clip here and to add clipping value, let's say 21.5 degrees here, and only mesh cells below these values, this temperature value, will be colored. So as you can see, we can also track the evolution by clicking on play, and only mesh cells value below 21.5 degrees Celsius will be colored. You can also, if you want, rescale the temperature in order to have a good color range. So that is very interesting too. Another good, interesting thing we can have and we can do with ParaView is to plot profile we previously set with graphic user interface of CodeSaturn. So I did this by opening both CSV files, so for the profile 16 and profile 32, and you can have the evolution of the profile step by step. So remember that both profiles represent the temperature evolution in a cross section of the tube. So here you can track the evolution at the bottom here of the section and at the top of the section. And at the top of the section, the temperature reached 38.5 degrees Celsius, while, for example, for profile 16, the bottom of the section is down to 18.6 degrees Celsius, and the results are similar to what we previously saw in the layout one, where profile 16 is located somewhere here, while profile 32 is located here. And as you can see in the bottom, the temperature flow, temperature is down to 18.6, while at the top it is still at 38.5. So this concludes this video tutorial. Thank you for watching our videos. You can keep tracking Code Saturn updates by checking on our channel or social media to get the latest news.